And we're live.
Yeah.
Welcome to the third presentation. We have Philip Hoyt. How do I say it? I'm so sorry.
Hey, yeah.
Hoyt. Um, yeah, I'm really I'm humbled and I'm very grateful to have speakers from all around the world. It's my fault for not being acclimated to all these different languages, but I'd like to give a brief introduction to Philip. He is a founder of Different and co-founder of Twin Fox AI. He is a top-tier expert on model-based linked data products, and he has over 25 years of experience as a consultant across retail, information technology, and food packaging industry sectors. He's been providing knowledge, B2B integration, and cybersecurity services for that time. And yeah, with that, I'll leave you to it, Philip. I hope to learn something from you.
Great. Thank you so much for inviting me. So looking forward. So ladies and gentlemen, Joachim, thank you so much. So I should say good evening, good morning, and good afternoon for those of you that are here in Europe or in Sweden where I am. I'll be talking about deep tech in the human loop. So let's go about it. There we go. So as with Different, that's the company. Twin Fox AI is the hypergraph platform that we developed. And so I've been working mostly in enterprises with 15,000 up to 200,000 employees. So those are the big enterprises and various roles, as Joachim said. And I've been looking for 20 years to really have this model-based cross-organizational information exchange systems in place. And I was missing many of the parts. So I figured in the end, I actually create a platform in the way that I wanted to be shaped. So with the advances in AI, we entered the algorithm economy, and it won't slow down from here. We often express how we're pleasing the algorithm. The algorithms are actually steering a lot of the things in the social platforms and everything that we do. I want to make the average business professional also be able to drive towards having high quality structured information and exchange that and be able to engage with algorithms and use algorithms and be augmented by them in their daily work. So all of this has a term, algorithmic business thinking. This is, I think, where we are heading to actually augment human beings. That's the right way. AI looks like magic, and like Arthur C. Clarke in his third law said, any sufficiently advanced technology is indistinguishable from magic. And I think he's right. We're being mesmerized by AI, generative AI, that provides answers that feels like a human would be creating them. Web 1 and Web 2, they both looked like magic when they came, and we're about to enter Web 3. The blockbuster application is not here yet, but we see that blockchain, generative AI, many other technologies like the metaverse, etc., are kind of converging into one. So we'll see exactly what comes out of that. But what all of these things have in common is that they require high-quality structured information. And we see that the business processes across the world need high-quality structured information. The guesswork, we all talked about hallucinations during the day and how we can prevent them, but we know that the models are there. We may have errors. So the bad data quality that we have in the enterprises compound these issues, and AI will only be as good, or the generative AI and other AI uses will only be as good as the data. So I want to ensure that we have meaning-oriented data with context instead of the presentation-oriented data that we often see. So there is no magic wand. It takes a lot of work, a lot of hard work to get there, but it's worth it in the end because it drives compound effect, and we'll come back to that. One of the key things I've seen over my 25 years is how much of cross-organizational collaboration there is, both within the silos of the enterprise, but also between companies. There's a lot of collaboration, and we'll only compound and get more. We will get cognitive sidekicks as well that we need to engage with information. One of the things we've seen is that 20 years, 30 years ago, we really started to, in the software engineering world, solve for these cross-organizational collaboration problems using a software called Git. And also the version control systems, there's a number of them. But that meant that we managed to get distributed collaboration. in part because the software engineers, they are controlling their data structures, but they also need a lot of feedback and quality improvement along the way with that solved by testing. So good data is at the heart of AI. I propose to solve those data quality issues with similar mechanisms for quality improvement, where we can test our data. We can use logic to verify that things are correct in them. And so trustworthy, high-quality structured information rests on model-based systems we can test and that we can explain. Lineage and provenance of data through version histories is critical, and I think that the many worlds that we see in Git is actually applicable as well for data. That's called branching in software, and I think many worlds is something that we could use in the knowledge graph world. So think something like software repositories, but for information, for linked data. Generative AI results are useful, and we'll be focusing on symbolic AI to get the good data quality foundations. So we'll come into this world of semantics and models. And many people cringe when they start to hear semantics, ontologies, taxonomies, etc. So I won't go deep into that. It's not a knowledge graph conference after all. But in terms of the models, they are important for driving a lot of things. And if we look at the world of information models, we see that we need structure around the information that we have around the data. And this is the world of ontologies and taxonomies. They define how the information may look and how it may not look. We have the big data and analytics, the data science camps, the data analysts. They are working mostly in tabular structures or in databases where you need to make a lot of joins in general, or columnar stores for that matter. Software engineers like data structure objects in memory or serialization of objects through APIs. And JSON is the common way of exchanging information here. In the middle, we see that Web3 is emerging. It all needs contextually aware data to drive all of the use cases. And so there's a lot of structured information that needs to go into Web3 to make it work properly in every single use case. For that, we need better tools to capture, manage, and sort out the data. And I believe that knowledge graphs or hypergraphs are a very good solution to be able to improve the information over time. The domain experts are relatively few, and they need to engage with all of these different constituencies in the enterprise for the data. So if we give them better tools, they would actually be able to do more of that work themselves, and it would be easier for everyone. This is important as well as machines start dealing with knowledge. And what does this mean for us in general, all of us? That means that we see convergence for technologies and for how people are collaborating. How to solve this then? I think it's portable linked data products. So linked data is a way of using good identifiers that are global addressable. The portability is important so that we can actually move data products between organizations or within the organization, and we can give feedback in small chunks of information. I'll come back to that in a minute. The way I think this should happen is through model-based hypergraphs. Hypergraphs are, in essence, knowledge graphs, but where you have the possibility not to only link two nodes, but many nodes using the same edge. This gives some extra abilities to actually hold good information. So you want to do controlled processing of structured information using rules. You build information structures that can hold structured information, and you use logical rules to both check the information, extract the information, and the three together means you can specify, create, validate, and extract and analyze information effectively. And it gives you the necessary guardrails to do that collaboratively as well. I call these the logical twins of information. So let's look a little bit about how to get about the information quality improvement in an enterprise. And we use some ideas here from the world of quality, where we have the 1, 10, and 100 rules, where we should probably apply that to for information quality as well. It costs about $1 to prevent a quality problem, $10 to correct the quality problem, and then $100 to do nothing and let it lead to failure. So I want to stop these problems early on in the information production toolchain. So by using business rules and information, that we can get or with structured information, we can actually get there. So let's look more into this. How can we leverage model-based hypergraphs? If we look at that, we want to use standards-based structured information to our advantage. That means the information that we store is stored as a graph. We use the resource description framework, which enables us to use IRIs. Triples have identifiers to them, and we don't look at the individual triples. We actually look at the atoms of knowledge. We rather use information objects. Information objects are easy for both software engineers to work with. They use it as JSON linked data, meaning that every single object within a JSON is actually typed and has an ID. We can recognize it. We have global content addressable information everywhere. And we can transport one full document between systems and using APIs, and we can recognize it as domain experts. In a hypergraph, Edge connects more than one node. So in a regular triple store, we have one node, we have an edge, and then we have another node that is a triple. In hypergraphs, we can have sets and lists and n-dimensional arrays at the other end, or at both ends, actually. And what I'm focusing on here is to have a directed hypergraph. So we want as well to have a transactionally ensured information structure. The schema should ensure that the model is always correct. You can never enter any data. You need to ensure that at the transactional level, the data that comes in, the added triples, the added objects, actually conform to the model before they're loaded. So you can have a system of record. You shouldn't be able to commit unless it's correct. And you can work locally, but then when you sync with a central system, it should say no if the schema has been updated since. And here we come to the Git-like collaboration. I believe that with a data store, you should be able to clone it. You should be able to push and pull changes and take small sets and merge or rebase those sets onto another data store. So you can have multiple branches, one quality branch, one production branch, and one dev branch, and you can create local changes and then submit them into the central store. Or have multiple central store at different companies that actually exchange information when they're online or, again, after an intermittent failure. This brings us version history as well. We should be able to go back in time. We should be able to have a many worlds or a branching approach. So this way of working with information structures enables a lot of AI use cases with high quality data and high quality information that actually is contextualized. And that takes us to explainable AI, reasoning using paths. A data log is a subset of Prolog or another logic engine that is specifically geared to work with a knowledge graph and removing all of the logical paradoxes that you might have if you go with a raw logical system. So data log is perfect for many of these use cases. You should be able to export to triples for existing graph processing using Shackle or other validation tools where you want to go beyond the business rules or beyond the data log processing. You should be able to visualize how and the thinking behind how you actually work with the graph. And you should be able to store, in my view, you should be able to store the rules as part of the linked data product that is portable and movable. So this is our vision of a linked data product and what it should look like. Model-based, using symbolic AI, using JSON-LD as a transport format for ingestion and for taking data out, and for collaborating using APIs. Having linked data, it should probably be a hypergraph. It should be friendly to all of the domain experts. You should have some kind of a Visual Studio, not the Visual Studio Code, but I'm thinking of a studio product that actually helps you to build the graphs, to build the models, to build the structures. And this takes us to using rules to get 100% correct information. That's a bold claim, but it is possible when you think what 100% correct information is. It is to the rules that you've specified. Then you can actually say that you're 100% correct to those rules. And you have many ways to validate that the information is correct. Wider, narrower associations in the structures. You can look for the data, the content. And this is what people in the financial world that I talk to needs. They see that, well, we can use generative AI to get to a 50 or 60 or 70% accuracy, maybe up to a 90 or 95%, but that's not good enough for processing financial statements and reports. There you need 100% correctness to rules. You need to know exactly what the AI does. And here you need these kinds of information quality checks. So what changed and what enabled then this journey so that we actually, because we had Prolog, we had these tools. I mean, Prolog was invented in the 70s, and we've had these for, 50 years almost. But something changed recently. We started to get enough memory to be able to host really big data sets. If we look at the Amazon EC2 engine, I think we can go up to 26 terabytes of data in memory. This means that the world has changed since. And one of the important things is that the entire world actually, in our viewpoint of it, it went from predominantly linear thinking to seeing things as mostly complex and adaptive in our world. And that change enables us also to start thinking about how agents will collaborate, how multiple organizations need to collaborate and exchange data. And the same goes for teams and individuals in an agent-oriented world and a gig economy. You need to be able to work on a localized, specific data set and bring quality changes to that. Similarly to how software engineers have been working very successfully for the past 20 years. So from the 90s and the failed expert systems then, what happened is that we have significantly better hardware, and we now have the ability to actually constrain and properly create good expert systems. Semantic knowledge bases, those were really hard to create because we didn't have the semantic foundations in the 90s that we actually do now. We have some object databases, but the world changed since. So being able to have subclassing, superclassing, and cardinalities and everything else available to us in a visual environment suddenly makes it possible to build model-based hypergraphs as a foundation for symbolic AI. You can build in transactional constraints. You can have JSON LD graph objects and more. This enables rules and reasoning on very advanced and complex data sets. So everything can be loaded in memory, almost no matter the size. I think this is Prolog's second coming. And you use rules and logic to verify the information that you have. So this takes us to the two types of AI. You have statistical AI and you have symbolic AI. The statistical AI, as we've been talking in the previous talks as well, we have stochastic models. You train a model to get an output based on the input on the prompt. It should give you a meaningful result most of the time, but you need to be very watchful for hallucination and ensure that you remove those as much as you can so that they happen very infrequently. When it does well, it gives a result that is way better than chance. It's often correct, but how can you actually trust it? Well, you need to test and verify, but you always run the risk of having some bad response. So that is something that we need to be aware of with this technology. It's fantastic for when you purpose it correctly. The symbolic, on the other hand, does not have this creative ability. It operates with 100% accuracy to a set of rules. It doesn't do anything that you haven't programmed it to do. Sometimes that is exactly the kinds of AI you want. And it gives deterministic, repeatable, and explainable results for every response. So we can trust them. So it's really two different paradigms. And as we'll be exploring further, there are so many different kinds of AI. It's a big umbrella for many technologies. Combine them to get the accurate results that are needed. So if we look then at the difference between statistic and symbolic AI, we see that we have generative AI on one side, maybe this. So take a summary of something or expand something, bring the analysis of something, and we get that. And with all of the data, using RAG, for instance, as the previous speaker talked about, Ananda Ganesh, we can actually generate based on information we have so that we get very precise and good answers. Using explainable AI, we make a conclusion based on logic, but we need to create those rules, and that can be extremely expensive. We can at some point maybe get some help from, or we can get some help from generative AI, but we also need to know what we're doing. So we get exactly this. This has taken us to a place where we need to think about what AI is. And I'll spare a few minutes here to start thinking about the kinds of AI that we create. Should we be creating competitive AI that competes with humans? Or should we think differently about this problem? So generative AI often helps us to create things that actually remove the work from us. And that means that we may actually have some of our organizational knowledge that is removed because we replace that one, instead of augmenting humans to actually do things better and faster using generative AI and other technologies. Here is where I think that AI should really be put in place so that we start thinking about how can we augment humans. That should be the primary focus, because with RPA, with other technologies, we get this potential for losing organizational knowledge into the systems, and then we lose them forever because we don't have human beings where we can go back in our business continuity plans, etc. So if we look at competitive AI, that is one part of it. I believe in complementary AI. Complementary AI is where it augments us humans. It's where we create processes. It can be almost the same and almost the same levels of augmentation, but it's really a machine in the human loop. We'll come back to that. So the complementary AI, that is, for instance, if you think of a memory castle, that means you're actually thinking about a location and you put things in there in your mind. You actually get better at remembering things. Using maps and using an abacus, you actually get better at the mathematics at the core. You don't get lazy. So I think that is the frame of mind we could have when we're exploring AI. AI should make us better, and that is something that we should look for in complementary AI. So this is what I believe in. The information processing core of a logical system comes as a logical twin that incorporates all of these things for the symbolic AI parts and for dealing correctly with data and getting better and better information quality. So if I summarize here, I think that it's important that we use the right AI tools for the challenge at hand. There are many tools available: generative AI, vision AI, we have machine learning, we have symbolic AI that I talked about today, and it's really a big bag of things to pick from. But all of them, in one way or another, need accurate data, and that is something to plan for. So use generative AI for good enough, fast, and/or creative results. And if not for creative or fast results, ensure that it's properly constrained in a good way. Check the results, ensure that the prompting is improved. Use logical rules and shared vocabularies for correct data so that the enterprise invests in this. Combine the tools into a stack, each for their individual strength. Explore RAG, as previous speaker, with hypergraphs or knowledge graphs. Get compound interest from investing in a semantic stack where you define the information structures, you use objects in your thinking around data so that you can actually capture the entire semantic richness. Use data products and for the data product collaboration. Empower the domain experts with better tools and use clear common definitions, term databases, vocabularies, etc. Commit to the shared vocabularies and definitions. And we see that the uptake now in ontologies and taxonomies, we see that they are picked out of school immediately because the large enterprises really see that they need to invest in this. So invest and align with standards and other industry peers. Try out modern tools for linked data product collaboration. I think that is a way to go as well. And I would summarize with this: put machines in the human loop. When thinking about how to put machines in the human loop, ensure to think about the UX and just not assume that the user don't want to get better, but actually help them with nudges and use AI to actually check answers so that the human being actually gets better at the work over time. And fight the unnecessary complexity for most of the human beings. And I believe that computers exist to augment humans, as said. So that means that we need to flip the script. Instead of talking about keeping the human in the loop, more think about how do we actually put the machines in the human loop and augment people. Thank you. That was all that I had to share today. So I think I'm a bit ahead of schedule. So Joaquin, thank you so much for.
Yeah, it's been a pleasure. And if anybody has any questions, feel free to ask in the comments. I'd like to start just getting a little bit from your background. Initially, you started out with retail companies to help them with their resource planning, right?
Yeah, so it was a lot of integration. So it was long-term planning for data centers and for data applications. I actually looked almost 50 years into the future, planning for changes in how systems would be run in the data centers. And you can't really look 50 years into the future, 5 decades, imagine that, for a specific system that we're planning for. But this has helped me to really look long-term into how to leverage technologies, and I've seen that you get compound interest from investing early and doing things right. And that also paid off when we were working with integration. I worked with integration at a large company that did mobile phones, and we had a canonical information model that actually tied the entire business together with 1,300 individual document flows that each had a canonical model for their information collaboration. And it was XML based, but I would say that we would probably have done it in JSON LD today had we had the chance, because it was that semantic in nature. So that is where I started, and that is also where I got the inspiration for doing things the way I do.
Yeah, when you say integrate systems together in a B2B environment, that leads me to think, where is the fragmentation coming from? It's the app-centric thinking, right? You solve localized problems, and you're like, okay, now this is solved. How do I integrate it to something else, right?
Yeah, we usually don't stop, and sometimes it's not worth it. So I would say that with a caveat. I would say that sometimes when you're small, it doesn't really make sense to go outside of the systems. But sometimes you need to create systems for your competitive advantage. That is where you are the best in the world at your specific individual business process. And that is probably where you should be starting to actually start defining your models around that individual transactions, how they work in that environment. And usually you would be going further than the systems that you can procure. So I would say that is probably the first location to go information-centric, to start with the data product around that use case, and then build around that with the systems around it, actually working with the data. So you can easily replace the systems around your competitive advantage, your competitive moat. And that brings faster and faster ability to deal with that competitive advantage. And then you can see how much is actually fully standard. Of course, you should use standard system for that, because that is not where you're best in the world. So you need to find the right data processing facilities for the enterprise. But investing in ontologies, investing in in correct and structured data is super important.
One thing that I find refreshing about your approach, and you made it a point in the presentation, is the idea of version tracking knowledge or version tracking models. I mean, an organization doesn't stay the same size forever. You hire employees, you get new accounts, you diversify your product offerings or service offerings. Things change. So you have to make it open for change.
100%. And so I believe that it's important for anyone to be able to programmatically change the model and slowly move it so that you actually have a development branch where you can change both the model and the content and change it to what you want and actually propose a change. And then you can look at those. You can actually test that the entire model actually behaves the way you expect it to before you're rolling out a change of schema, because you have the rules for everything recorded in your data product for that specific area. So this becomes kind of a built-in data contract, but goes way beyond, because you can use logic to test that contract to be correct for all of the data that exists, and also move the schema and data correctly using the studio and using the logical tools.
Another thing about the modeling aspect is that you can track the flow of information, right? With those validations, you can evaluate which areas are showing areas of concern or bottlenecks or problematic situations, right?
Yeah, and this is what the reasons that I see a lot of interest this in financial reporting, because in essence, the financial reporting tool chain is run by Excel today. And if we look at that one, there's a lot of opportunities to actually use a knowledge graph or hypergraph approach for this one, to take blocks of information that goes into a report and start validating step by step and improving the entire chain of information production. So you can get that, you can look at that as a manufacturing tool chain where you can actually improve that step by step. As you introduce more rules, you start to learn about how to do that in effective ways. So this transforms the uniqueness of every single company has their own way of producing their financial statement, because every business is unique. So that is one of those areas where you really need to create your competitive advantage, where you can automate those processes and building the guardrails and bumpers so that you can keep the financial accountants, and they can help themselves to actually improve the process over time. So that is one of the areas, in addition to cultural heritage, BIM, and other areas that want to connect a lot of information, use correct data structures for doing so. Yeah.
And in modeling the enterprise, you make the implicit rules explicit. So that's part of the consequence as well, right?
And also you learn why you're doing things. It's not just an implicit assumption. You actually make it explicit. You add the tests. As you do in software, why are we doing this? Well, let's look at the tests. And then you look at the unit test cases, and you can actually see why you're doing things and if you're doing it well. And the same goes for data as well. Why do we do it this way? Well, we have a model for that, and this is how we version the model. So what happened in the history, you can go all the way back. You can see the individual changes through the provenance and lineage of that historical model. You can also see the branches and where things came from.
Thank you very much, Philip. It's been a wonderful presentation, and if anybody wants to begin playing around with modeling, he has a platform that allows you to get started, get your hands dirty, and he's more than happy to take you through that process. We're going to take a short break, and then we're going to go on to the next presentation. But yeah, thank you, my friend.
Thank you. Thanks a lot.